Welcome to Waking Up with AI, a podcast from Paul Weiss, featuring your hosts Katherine, Forrest, and Anna Gressel. The only update you need on AI policy, law, and governance starts now.
Welcome to another episode of Waking Up with AI, a Paul Weiss podcast. I'm Katherine Forrest.
And I'm Anna Gressel.
And Anna, it's Thanksgiving week. And while this particular episode, as we know, is going to be played sort of after Thanksgiving has come and gone and we're into the holiday season and people are sort of trying to organize the 8 gazillion holiday parties, I just wanted to say that I love the Thanksgiving week.
Me too, actually. One thing that not everyone knows about me is I used to be quite a good baker, and I don't bake everything equally well, but I'm particularly good at pie baking. So I love this week. I love baking different kinds of pies and scheming up which ones I'm going to bake every year.
Okay, I just want to say that I am one of the people who did not know that you could bake because I have not been the recipient of not only not a pie, but a single baked good. Nothing. I have not gotten a cookie. There has not been a muffin. No cupcakes. Nada.
Injustice.
A total injustice. But one thing I wanted to say before we get on to something more serious is I was looking at the front page of the New York Times today, and it has the picture of the 2 turkeys who are going to be pardoned, right?
Yep.
And I was struck by the fact, I actually still am a former judge, that these poor turkeys are being pardoned from no crime, right? They have not committed a crime. And so I just had suddenly this moment of dissonance between pardoning a turkey that has committed no crime apart from existing and having a lot of feathers, and the idea of it being pardoned.
Katherine, I feel like that should be in the New Yorker caption contest. You should just enter that right in.
All right.
It's ready to go.
Well, let's actually sort of move on to our topic today. Well, actually, but even before we get to our topic, I want to say one more thing about the week because I'm not ready for our topic yet. You know, one thing I'm going to be doing this week is I'm going to be sort of moving along and trying to finish this book again that I'm co-authoring on called Of Another Mind. And I'm co-authoring it with Amy Zimmerman. And it's a fascinating topic, but one thing I ran across while I was doing I always want to make sure I'm up on the last minute research for this book. I don't want to sort of have the book come out and have something big have come out just at the very end. But there's a really interesting book that talks about AGI, artificial general intelligence.
Do you want to remind people what AGI is and why it's such an important concept?
AGI, which is a term that you're hearing more and more often right now in the press, is actually the point at which intelligence or reasoning abilities of AI can meet or exceed that of humans. And so you can think of it as almost a point of superintelligence, although there's something else, I think, that I would distinguish called singularity, which is really, in my view at least, not AGI. But AGI is on that route. And there are right now a lot of press reports about model developers actually seeking to achieve AGI with their models. And we can talk more about this another time, but I wanted to just recommend to folks Ray Kurzweil, Kurzweil. It's Ray Kurzweil's new book, which is called The Singularity is Nearer. He'd written an earlier book called The Singularity is Near, and this one is called The Singularity is Nearer. And whatever you think about AGI, I just wanted to recommend it as a good read, a really fascinating read for folks. And it's actually a building block, AGI, on relating to something that we're going to talk about today called scaling.
And I think the word scaling can be a little confusing. So, Katherine, why don't we start with a refresher on that? Because we don't want to just lose our audience before we even jump fully into the topic today.
Right. We had mentioned scaling a couple of episodes back, but we didn't dive into it like we're going to dive into it today. So scaling, first of all, is not descaling a fish. All right. So for those folks who think that when they picked this episode out called Scaling, that they were going to get a fish episode, that is not so. But it does get used. The word scaling does get used in the AI context quite a lot. It's one of those confusing terms. You know, I love the term agentic because it's sort of, I think, unnecessarily confusing. But scaling gets used also in a confusing way And I think everybody sort of assumes that everybody else understands it, and only actually a very few people understand it. So because of these multi-context uses of the word scaling, it's worth sort of diving into and defining it.
Yeah. So, I mean, I think our listeners might be familiar with some of the ways that the term scaling is used, like as a size metric. So, scaling something from a pilot program to a more general program, making it bigger, or spreading a use case out over a larger group of people. That can be kind of a concept of scaling up or scaling out.
Right. Or scaling can refer to increasing the size or the capacity of an AI model or system to maybe improve its performance, its capabilities, its efficiencies, a variety of different aspects of a model.
So let's just pause on that a little bit, because as a general matter, scaling can refer to scaling deployment or usage of a model. That's what we just talked about a minute ago.
Right.
And it can also refer to scaling model size. And so we'll talk about that particular point also in a minute.
And it can also, we can talk about scaling data, which might mean using larger or more diverse data sets. But equally, it can refer to increasing the compute resources that are used for processing.
Right. And compute is the hot topic these days. I mean, I think there's like very little that's more on folks' minds than trying to get their hands on some of those GPUs or graphic processing units that NVIDIA makes, or TPUs. Those are tensor processing units. So, when we think about scaling compute, we're really talking about the amount of computing or processing power used to train a model, or that the model has access to during use.
Absolutely. And then you can also scale tasks, which means to expand the range of tasks that a model can perform.
Yeah. And so let's go back today for our focus to talk about something that's getting a lot of attention in the press and has implications for compliance and governance issues. So that's particularly this question about scaling the size of the model, or put another way, scaling its capabilities. Maybe we can talk about why those are connected.
Yeah, and for this topic, we're going to back up and start with what it means to actually scale a model, apart from this now brief introduction that we've done. And what we're doing is referring to the efforts for this topic of what makes a model more capable, or at least theoretically can make it more capable. We'll talk about some of the limitations in a moment, and more powerful with regard to certain tasks. And in part, this can be done by training them in a way that makes the model larger overall.
So let's talk about what larger means. So larger here, in the concept of scaling, is measured by the number of parameters in the model and the investment needed to actually create that huge number of parameters. So we'll do a short refresher on parameters, which is another tricky term, sometimes kind of arcane term. But parameters are adjustable values within a neural network of the relationship of one piece of data or information to another. So, for instance, a parameter might suggest there's more of a relationship with one piece of data and the other piece of data. For example, cats and dogs might be related as concepts. And then trucks and machinery might also be related as concepts and less related to the concepts of cats or dogs. So there is a network of information about any piece of data that connects it to other pieces of data, and the values of the parameter or its connections changes as the model gets trained and can actually increase as the model.
In the context of AI, the weights is another word that's related to the word parameter, but it's not really equivalent entirely. Parameters are the internal values that a model has learned during the training process, and the weights define the connections between the neurons within the neural network where all of this is occurring. So you've got parameters as sort of a larger sort of grouping, and then weights within it. But going back to scaling, as more and more data comes into the model, there is more and more training that can occur within the model of the data that's there. And the model then learns the nuances and what connections there might be between the data. And like the cats and dogs example that you just gave, there can be a relationship between cats and dogs and, say, human beings because they're mammals, but there might be a different weight and connection between cats and, say, jungle cats in the rainforest than there are between cats, house cats, and humans. They might all be mammals, but there can be a different kind of weighting between one point of information and another.
Right. So as, these models grow, as they become bigger, there's usually a concept of having additional parameters, kind of a larger parameter size of the model. And larger models, models that are actually scaled up with all of that additional training, like so much training, are often, they're not always, but they're often models that perform best at various tasks.
Right. And the scaling itself is a complex engineering task that isn't done in just a single way. It's not just a matter of turning up the compute and throwing in more data and extending the length of time that you do the training. There can be and there are very, very sophisticated ways that are proprietary to many companies in terms of how they actually scale a model. And there are balances that different companies have between these different aspects of what levers can be used to scale the model, whether it be data or compute or any other aspect of the model. And last summer, we talked about a publication, maybe it was even in October when we finally aired it, but we had a publication that we talked about called Can Scaling Continue Through 2030? And I'm still recommending it, and it's from Epic AI, and it really lays out the different aspects of what is needed to scale and whether or not things will be scalable continuously through and up into 2030 and what would happen then.
And I think is it Epic AI or Epoch AI that published that, Katherine? I know you love this paper.
It's only you who would call it epoch. Like, what kind of word is epoch? There is no such word as epoch. There's only the word epic. So I don't know.
We'll take this debate offline, Katherine, but let's just talk about like the debate in the paper on whether scaling necessarily leads to better models. And that depends a lot on a lot of things like the architecture of the model, how it's trained, what it's trained on, and the type of task that the developers intend it for.
Right, for sure. And without getting lost in all of the details of this, so we could talk more about sort of scaling itself, the paper talks about the possibility that by 2030 we'll be able to scale a model that'll be 10,000 times larger than GPT-4. So that's 10,000 times. So think about something that is twice as large, or 4 times as large, or 10 times as large, or 100 times as large as GPT-4. We're talking about 10,000 times as large as GPT-4. And there's something in the world of computer science that's called Moore's Law, which relates to this concept from Gordon Moore, who co-founded Intel, that the number of transistors on a microchip would double every 2 years and the cost would decrease. But there really isn't an equivalent of Moore's Law in the AI world. And so it's not the case that as the model size grows or the data set size grows or the compute power grows, that there necessarily has to be an increase in capability.
Yeah. And I mean, there's so much debate around this. And I think we can talk about this. We can keep talking about this. Some people talk about more than Moore's, the idea that as architecture gets even more complex or quantum computing kind of comes to the fore, we're even going to surpass Moore's Law in really interesting ways. But at the same time, there are some people who are saying that this kind of exponential increase in capability and size can't go on infinitely. And so there might be some diminishing returns on scale. That's a hotly debated question right now.
Right. And there are articles, I think, a number of articles actually on exactly this topic, that some developers are not seeing the capability improvements that they would expect, but also there's now, and you'll see this a lot with some of the newer releases, you can actually see models that have fewer parameters than some of the big flagship, huge models, but that have really impressive capabilities.
So some people like A16Z's Ben Horowitz have placed attention on the hardware used to train AI, saying we're not getting the intelligent improvements at all out of the increasing number of GPUs to train AI. But the one factor everyone points to right now in terms of this debate is data.
And we'll come back to that in just a second, but I wanted to point out that, going back to something that I had just said, that when we look at like the llama herd of models, it's a very powerful model set. You see 1 billion parameter models, a 3 billion parameter model, but also the 405 billion parameter model, which is sort of the flagship model, all of which were released between July, which was the 405 billion, and then September for the 1 and the 3 billion parameter model, all of which have incredibly impressive capabilities. So even with the smaller models, we do get these impressive capabilities.
Yeah, I think that's right. And smaller models and larger models can be good at different things. They can be used for different things. One thing that's great about small models is you can stick them on devices. We'll talk about that probably in a different episode. But there are all these questions again about like, how do you even measure these capabilities? But let's pause and go back a little bit to the computing power piece. One thing that developers have used to scale models over the past few years has been by accessing a combination of computing power. And so that's for some developers buying thousands of GPUs, which are kind of like the scarce resource these days, and funding new data centers to house those GPUs and using new data sources to train models. So all of those things kind of come together to help with scale. But there are also now choices about when scale helps and when additional scale is unnecessary. It may just use up additional resources without return. So there's kind of this complex balancing act between what you're actually training the model to do, how it's going to be used, what the design is for. Again, like, is it supposed to be on device? Is it supposed to be this large model powering new kinds of capabilities? And so companies are making these really interesting trade-offs and choices just given the cost constraints on one side and the value or the ROI on the other.
Right. And then let's go back to that data point that you made a moment ago and assume that a developer wants to scale, but there really is a finite amount of data on the internet or available on or off the internet. And recent model releases are expected to have trained on pretty much all of the data that can be accessed. And there are some who say that we're about to hit or have hit or are past hitting something called a data wall.
Yeah, it reminds me of there was kind of this famous quote, I think it was as early 2023, Katherine, saying, we no longer have a moat because everyone has the same data. There are different kinds of moats that people are thinking about now and like differential value that's going to come from new areas. One of that could be new kinds of content partnerships to find more data, to get different kinds of data into the models. Some people, like some developers or kind of bespoke organizations, are actually working to develop more data from scratch. So they might be having like PhDs write new papers to train a model or provide really sophisticated answers to template questions. They can also use something called synthetic data. So then that's a super interesting concept. But that could include things like data generated by another model.
Right. And we haven't seen this next generation of models yet that will be trained on, let's just call it data beyond the wall. Hey, we could do a whole episode on data beyond the wall.
Sounds like a sci-fi series.
Right. It's a sci-fi series, Data Beyond the Wall. But we're going to see how it all sort of, plays out. But we know for sure that there's going to be additional development, and undoubtedly people are going to sort of work on the ways to best solve this problem. So we'll come back to these developments. But I just wanted to say, in terms of governance and compliance issues, as these models scale, it's very important that in-house, for instance, legal departments understand what the implications of that scaling are, whether it's to roll out certain kinds of capabilities within their organization, which would be task scaling, or if it's capability scaling, whether or not it actually triggers some of the EU AI Act risk categories. And so I think that there are going to be scaling implications for the in-house folks in our audience.
Yeah, I mean, it's such an interesting time. We haven't really seen the full scope of this next generation of technologies, and it's hard to see exactly how it's going to pan out. But one thing we can point to with certainty is that companies are really beginning to explore this seriously, and we're going to be looking at, models that are trying to surpass any plateaus in different ways, and that'll be its own kind of competitive exercise.
All right, that's all we've got time for today, and I hope folks are enjoying their increasingly cool holiday season that's starting now. And I am Katherine Forrest signing off.
And I'm Anna Gressel. Make sure to like and share the podcast.
Thanks for listening to Waking Up with AI. Be sure to subscribe in your favorite podcast app to stay up to date on the latest in AI policy, law, and governance. For more information on Paul Weiss, go to our website at www.paulweiss.com. This podcast is not intended to provide legal advice, and no legal or business decision should be based on its content. Past results are no guarantee of future outcomes.